Continuing graphing functions from last time, we're going to be looking at what's called function notation in these notes. Not only what it is and how to evaluate it, but then also how to use it to graph a linear function. So when we talk about linear functions, there's usually two ways that they are written: XY notation and function notation. Now, a normal XY notation is what probably we're all used to. Here's an example: y equals 2x plus 3. So that's an example of a function in XY notation, and you can see x and y are both present in that function. Now, the same function written in what's called function notation looks like this. Instead of y, we use f parentheses x, and that's read usually as f of x, and then just the rest equals 2x plus 3. Now what this does is it sets up a few pieces of information. The letter f, and it could be G or H or really any letter could be used here. This is the name of the function. So the f function or the G function or the H function, whatever letter is here, this is the name of the function. Now whatever is inside the parentheses, and it's usually x to start out with, this is the input value. So whatever we put in the parentheses here will go in for x in the actual function. And the rest of it right here, 2x plus 3, this is the actual function. So this entire statement here would be read as the function f of x is 2x plus 3. And that's how you would read that. And so for our purposes here, this doesn't work too differently from y equals 2x plus 3. It just allows us to use it in a way where we can put in a bunch of different input values and get a bunch of different values for the function. And you'll see what I mean with some examples here. So for example, given the function f of x equals negative 4x plus 10, we want to find f of 3. And so what we want to do here is, instead of x, put 3 in the input area, and then in the function, replace every x we see with the number 3. And then we're just going to evaluate that. Now the f of 3 part, that's just the name of the function, remember, and the input value. It's not needed for this next part. So just evaluate the work. Negative 4 times 3 is negative 12. Then we have to add 10 to it, so it's negative 2. So we know that the value of f of 3 equals negative 2 here. Now if we do that over and over and over, if we repeat that a few times, we can then get a set of points and use that to draw a graph. So for example, we have f of x equals 2x plus 1. Now let's put these values in here for x, 4, 0, negative 4. And we're just going to put each of them in for x. So for the first one, it's 2 times 4 plus 1. Well, that's 8 plus 1, which equals 9. Or 2 times 0 plus 1. That's 0 plus 1, which is 1. And then 2 times negative 4 plus 1. That's negative 8 plus 1, which is negative 7. And what this has given us are the ordered pairs 4, 9, 0, 1, and negative 4, negative 7, which we can then put on the graph. So 4, 9 is first, and that is right here, and that's the point 4, 9, right? It's the first input along with its output value. 0, 1 is next, and then we have negative 4, negative 7 down here. And if you can look, all three of those points are in the same straight line, which we can draw right through them. Okay, so that's how we can use function notation to draw a graph. We can fill out a table of values using the function and then graph the line. This is also sometimes called a t-chart. You might see it drawn like this with an x and y as a t-chart. It's the same thing, x and f of x and x and y. virtually interchangeable here for our purposes. Now, if you have a fraction in front of your x, like we do on this next example, we want to use multiples of the denominator or just numbers that are divisible by that number, because we will have to divide. So in this case, let's just go ahead and use sixes, like -6, 0, and 6. We could also use -3, 0, and 3, or 12, 0, and 12, and -12, 0, and 12. Anything that will divide evenly by 3, because that way we will get a whole number for our f of x or y value. So let's just plug those in. We're going to do 1/3 times -6 minus 4. So now again, we're multiplying by a fraction, so we have to take that number, multiply it by the top, which is just 1 here, and then divide by the bottom. And that's why we want numbers that are divisible by 3, because then it will divide evenly. So -6 times 1 is -6, divided by 3 is -2, and -2 minus 4 is -6. Now let's try 0. 1/3 times 0 minus 4. Well, anything times 0 is 0, and 0 minus 4 is -4. And for the last one, 1/3 times 6 minus 4. Well, 6 times 1 is 6, divided by 3 is +2 this time, minus 4. 2 minus 4 is -2. So we can put those on the graph. -6, -6 is left 6, down 6. 0, -4 right here on the y-axis, and 6, -2 is right here. So once again, we have a nice straight line. And since we know how to graph a line using slope-intercept form, we can confirm that this line does start at the b value of -4, and the slope up 1/3, it does meet that criteria, up 1/3. Same thing with the other example, starts at 1 and goes up 2/1. So we can use what we know already to confirm that the line we get is correct. So that's how you use function notation to gather points so that you can graph the line. What's nice about this, because even though using slope-intercept form is quicker to graph a line, this works no matter what our equation looks like, and it also works for nonlinear functions as well. So you can use this process to graph any function, not just a linear one.